Independent events. A and B are independent events if the chance of A occurring doesn't affect B and the chance of B occurring doesn't affect A. And in order to show that two events are independent, you have to only show one of the following. So if one is true, then all three equations will be true. So let's take a look at an example. So the example says, let event A taking a math class this term. Let event B equal taking a science class this term. It says given the probability of A is 0.6, probability of B is 0.5, and the probability of A and B is 0.3. It asks us to show that A and B are independent events. So we need to pick one of these three equations and verify that it's true. So because we have all of this readily available, this bottom one, the probability of A and B equals the probability of A times B, this is the one that we're going to use. So what we're doing is we are going to try to show that these equal, and if they do equal, then we know that A and B are independent events. So the probability of A and B is 0.3, and the probability of A is 0.6 times the probability of B, which is 0.5. So we'll get our calculator, and we will do 0.6 times 0.5. You can do it in your head as well. And we do find that they are equal. So we can say that A and B are independent events. So with independent events, sampling can be done with replacement or without replacement. With replacement is when each member of the population is replaced after it's picked. So you might pick something and then you put it back. And that member has a possibility of being chosen more than once. So when sampling is done with replacement, then the events are considered to be independent, meaning that whatever you get for the first pick won't change the probabilities for the second pick. Now, when you look at without replacement, this is when you sample, but you don't put it back in. So once you pick something, it doesn't go back into the population. So each member of the population can only be chosen once. In this case, the probabilities for the second pick are affected by the result of the first pick. So the events are considered to be dependent and not independent. Let's take a look at an example. So in my pocket, I have 2 blue tickets, 3 red tickets, and 5 white tickets for a total of 10 tickets. They all feel the same. I can't tell the difference when they're in my pocket. In the first example, I'm going to pick a ticket at random, then I'm going to replace it and pick another ticket. So what is the probability that I pick a blue ticket both times? So a blue ticket, I've got 2 out of 10. So the probability the first time I pick it out is 2 out of 10. I put it back in my pocket. There's still 2 blue tickets. So the next time I pick, the probability is still 2 out of 10. So I get 4 over 100, which is 4%. So I have a 4% probability of picking a blue ticket each time. Now let's look at without replacement. So I pick a ticket at random and I don't replace it. I don't put it back in my pocket and I pick another ticket. So what's the probability this time that I pick a blue ticket both times? So the first time I pick the ticket out, the first time I reach my hand in my pocket, there's 2 blue tickets out of 10 total tickets. So I pull, and let's say I pull it out of my pocket. I don't replace it, so I set it aside. Now when I reach back in my pocket, now I only have 1 blue ticket left out of 9 tickets. I don't have 10 tickets in there anymore. This is important. I only have 9 tickets left. So it's 2/10 times 1/9. And I get a 2.2% chance probability of picking a blue ticket both times without replacement.